If you have made it this far, then you have accomplished something that's pretty amazing. You built a simple robot with basic, inexpensive components, capable of maneuvering with precision. This allowed you to write a program to navigate a maze. In addition to controlling motors and reading sensors, your program gathered information about its environment and stored it using a framework that modeled the real world. You then created an algorithm to sift through this information and find a path through the maze. Gradually, you developed a program capable of handling uncertain situations intelligently. Now it's time to take things a step further. The real learning occurs when you apply what I taught you to improving your robot. Micromouse tournaments score participants based on how fast their mouse can navigate the maze after it has been mapped. This involves trying to find a faster path to the target cell once you've reached it by returning to the starting cell. Once your robot reaches the starting cell, you're going to want to program it to do what is known as a speed run. That's where it travels from the start to the target as fast as possible, as you will see here. Notice the robot doesn't stop when it goes from one cell to the next. It's rounding corners and traversing the maze without ever stopping. One way to make your robot go a little bit faster is to change the default power level we set in the NanoMouse Motors class. In the videos I suggest 100 to make programming easy, but the motors actually top out at 200. Now we can't set the power level to 200 because the motors need room to go a little bit faster and slower in order for the proportional control algorithm to work. That said, you should be able to change these numbers to maybe 150, maybe even up to 180. I don't know, you'll just have to try it and see for yourself. You also need to remember that when you change this number, it will impact how long it takes your robot to turn and how long it takes your robot to move from one cell to the next. Because your robot's moving faster, the amount of time will be less, and you will have to adjust your functions accordingly. Another way to make your mouse go a little faster is to improve the hardware. Here you can see that I've replaced the breadboard voltage regulator kit with a voltage regulator plugged directly into the breadboard. I still have some capacitors and a switch set up just like the original regulator, except that this setup allows me to power the mouse a little bit differently. I can energize these power rails to different values. The right hand one is still at 5 volts using the regulator on board the Arduino, allowing me to power my sensors as well as the Bluetooth module. This allows me to power the left rail at a higher voltage. If you're still using the servos recommended in the course, then you'll want to use a 6-volt regulator. However, if you have opted to upgrade to Parallax's new high-speed continuous rotation servos, then you'll want to use an 8-volt regulator. If you do that, you'll probably want to upgrade your battery as well to a 3-cell LiPo. While the battery itself doesn't cost too much, the charger for the battery, the power supply for the charger, and the cable to connect the charger to the battery, as well as shipping to get everything to you, does add up. You're looking at probably around $50. Having made this upgrade myself, I can't say that I recommend it. Instead, knowing what I know now, I would probably have opted for a 6-volt regulator to soup up my existing servo motors. That said, it's your mouse. Have fun upgrading it any way you see fit.